Now we see next properties. Next property is variation of magnetization of superconductor with applied magnetic field. Means when we apply external magnetic field, how the magnetization in superconductor vary. First we see in type of superconductor how magnetization vary with change in applied magnetic field in the form of graph. So see along the x-axis the applied magnetic field and y-axis the variation in magnetization. Then we can observe as applied magnetic field increases at certain value of critical magnetic field, it lose the property of superconductivity and it becomes normal conductor. In type 2 superconductor, it is different than type 1. If you observe carefully, in type 2 superconductor, there is this magnetization is gradually decreases and up to the up to low critical field, it shows complete superconductor, and after that, as magnetization gradually decreases, there is mixed stage, that is vertex stage, and after higher critical field, the superconductor become shows normal conductor. Next point, state of material. Depend on the previous graph, we can show the different state. In type 1, there is only two states at temperature less than critical temperature and magnetic field less than critical magnetic field. That time it shows superconductor, and as magnetic field increases than critical magnetic field, that time the superconductor become normal conductor. Whereas in type 2 superconductor, there are three different states. First is temperature less than critical temperature and magnetic field less than lower critical field. That time this type 2 superconductor act as perfect superconductor, or we can say superconducting stage. Next, when field is greater than lower critical field and less than higher critical field, that time the stage is mixed or vertex stage. And when applied magnetic field is greater than higher critical field, that time type 2 superconductor shows a normal conducting stage. Next point is change in magnetization, means how magnetization changes. In type 1, the material loses magnetization sharply, suddenly at that point when external magnetic field more than critical magnetic field, sharply it loses magnetization. While in type 2, the material loses magnetization gradually, slowly it decreases. Next is critical magnetic field. The highest value of critical magnetic field in type 1 is about 0.012 to 0.2 Weber per meter square. That means its values is very small, 0.012 to 0.2 Weber per meter square. This value in type 2 superconductor can observe the highest value of higher critical field is about 30 Weber per meter square. So we can observe for type 1 superconductor, even we apply small magnetic field, it loses superconductivity. While in type 2 superconductor, up to 30 Weber per meter square, it persists its property of superconductivity. That's important point. So we're using these type 2 superconductor to form solenoidal magnets, which is used in different industries. So next point, the applications. Type 1, as it has having very less value of critical field, it has less industrial application. While type 2 superconductor having more industrial applications and it is more useful. And final point is the example. The examples of type 1 superconductors are aluminum, lead, mercury, etc. While in type 2 superconductors it is niobium, tin, niobium, titanium are the example of type 2 superconductors. This is about the difference between type 1 superconductors and type 2 superconductor.